Everybody seems to believe a diagram is the best way to explain an RNN. Well, here's mine. Criteria that define an RNN is that the hidden layer has a weight to its own previous time step. Every neuron uses a bias, and it seems most of the time we're using a hyperbolic tangent activation function, and a lot of people seem to use hot one setups with RNNs. The way that I was told how to do backpropagation through time is by using a window. So you stop every so many time steps. So this is a little bit tricky because when you do backpropagation, you start at the end of the window and you work backwards. When you get to the first step in the window, you need the step before that. So the way I do that is to store that in the length of the window plus 1. So for instance, if I'm using a window of 64 steps, then my array actually stores 65 time steps, and I write index 63 in index 64 at the end of each block, for the one preceding 0 at the beginning of the next block. And basically the backpropagation is simple enough that you can fit it all on my little screen. I'm really interested in observing how well the basic method performs. You can tell if you've written it properly by training on a short sentence to see if it overfits. And if it's not written properly, you might not be able to tell because I first wrote this 3 years ago and I spent a couple of weeks training it before I realized that my error quotient was never going to drop. So that's a good way to tell. I keep reading the people having better results using lstm than GRU for generative tasks. For training, the way I've set up my learning coefficient is to use powers of 2 because from what I understand, compilers optimize multiplication by powers of 2. You want to really wait until your progress is minimal before you drop the learning rate. Otherwise, you lose all the advantage that you can get. It really adds up. This is my first output. Training is a very different experience from programming. You basically have to wait for a long time and sit around and write numbers down. So I feel like Thomas Dolby holding a clipboard. I tried training it on some old development journals, but my vocabulary is much too dense for the results to be. I also tried training it on a combination of the Tao Te Ching and Palo Solari, and again, I also tried training it on the Tao Te Ching, and at 3 different time steps we have different results. The results seem to be passing different levels of language at different points in learning. I tried training on a longer file of Enid Blyton, Palo Solari, and the Tao Te Ching. I thought it would be a good combination, and I spent a lot of time training on that. Here's the results of that at different points, which are interesting. Something you might be interested in finding out about, Claude Shannon's work on the fundamental limits of English language, which it shows you what's happening with the error coefficient. If your model has a certain complexity, it might stall around 1.6, which has to do with letter orders as far as I understand. So the next thing for me is adding lstm.